Welcome to the physics lab. Today, we're going to be determining focal length. And let me tell you, based on your lab reports, that some of you need focus. All right. My lab assistant today is Bibu. Say hello, Bibu.
Hello.
That's hello, Bibu. You're supposed to say hello,
Hello, Bibu.
Thank you. All right. Now, what we have here is an optics bench. And we have these lenses. These lenses are made of a material called glass, which tends to break. And this we have is the lens holder. Now this has a little spring-loaded action. So what you do here is you take your lens holder, see, you open it like this. Do not stick your fingers in here. It hurts like hell. Trust me, I know. Ow. Okay, don't do that. You open it up, you take your lens carefully out of the black cloth bag, you put it in the center, and then you close the lens carrier. Now, I look like Sherlock Holmes, don't I? I just need a hat. All right. You put your lens on your bench carrier. Now, where should you put your bench carrier? I'm going to suggest this. If you look on this side here, you want to make sure that your bench carriers, first of all, if you have this kind of a bench, optical bench, you want to make sure that the little hole where you can read the numbers are on the same side as the numbers. Because if you put it on the other side, you're going to look like an idiot trying to read your numbers because you have the hole on that side, but the numbers are there. Okay, so put it at 55. That'll be good for you, trust me. Now, what we have to do now is figure out the focal length of this lens. Okay, how do we do that? Well, we're not going to do it the way it said in the lab book. Easiest way to do it is to focus on something that's infinitely far away. So Bibu, I want you to take this and move off an infinite distance away from the optical bench. We'll wait for you. Okay? Go ahead.
I'll never come back.
That's the plan. That's the plan. I've been waiting all semester to get rid of you.
Awesome.
Now, it turns out that across the street is pretty close to infinity. Or close enough. So we have the thing at 55, and what you do here is you have your target. And you move, you loosen up the set screw, and you move this back and forth until the image of across the street suddenly appears. I don't know if this is showing up well on here, but trust me, we can see across the street now. Somebody just walked across the street, and not in the crosswalk. We have evidence of jaywalking. We shall prosecute. Now we have the focal length. And it's going to be the difference between these two, which I'm not going to tell you, because they're all the same. You'll have to figure it out yourself. Once we're done with, now you type that into your spreadsheet. That's the easy part. Once we're done with that, you're going to get the source. Not the force, the source. And it says to start off 40 centimeters from the lens. So let's see, it's 55 plus 40, 95. Thank you, Bibu. And at that point, what we're going to do is we're going to shut the lights off. Bibu?
Yeah.
We're going to shut the lights off.
Where's that?
Those little switches on the side over there.
Okay.
And we're going to shut the drapes so it gets dark in here. It's time for dark business. Okay, we plug it in. Now we have a source. Why don't you come on over here just so they can see this, what the source looks like from this side. See, what you have here is a little couple circle target thing with an arrow in it, and the arrow points up. That's important. For those of you who don't know, this is an apometer. It's for people who don't know which way is up. All right. That would be a good number of people. All right. anyway, now what we want to do is we want to find the distance. We have to move this guy here until the image, and people, you tell me when it appears, appears on the screen in focus.
It's right somewhere there. Yeah.
I think I can get clearer. And you want to make sure you go back and forth a bit. See, it's going out of focus till you find the spot where it's most in focus. Let's say there.
Yeah.
Okay. Now, if you look at this carefully, and you can't see this because, you know, it's not that good of a video, the arrow, which way is the arrow pointing now, Bibu?
It's down.
It's down, right. Now, if for some reason your image is off the screen here, that just means you just have to adjust the heights on one of these things. It's not all that complicated. You can handle them. All right? Now, what you have to do is you use these calipers to measure, first on the image on the screen here, the length of the arrow. This would be H0 on your spreadsheet. Not HO, H0. The height of your object. Then 28.41. Keep in mind that this is in millimeters. You want to convert it to centimeters before you record it on your spreadsheet. So you only have to record that once. You only have to make that measurement once. So if we look here, we type in 2.841 centimeters. Then we go over to this guy here, and we measure the height of the arrow on here. And just because it's pointing down doesn't mean that the height is negative. Still just the length. And it's a different height. In this case, it's 2.652. So we type in for HI, this would be HI, 2.652. P is the distance from the object to the lens. This is 40. Q is the distance between the lens and the image. In this case, it looks like it's 5, 15, 25, 30, 38, I think. Doesn't matter. 38 centimeters. Keep everything in centimeters. And then all the rest of them are calculated according to the equations. We have 1 over Q, 1 over P, P times Q, P plus Q, M by equation 2, and M by equation 3. All right? You also have to have your focal length on here too. And you'll see some things. Then it says to repeat it. This time, though, we're going to change the distance from 40 to 50. This is why it's very important. You don't want to have one of your measurements made right on where the space between these things is. That makes it a real pain. It just makes your life easier if you do it like I said. So you put this here on 5. This would be 50. That's 105. 55 to 105. And then you repeat it again. And
Closer.
closer. People says it's closer. And he's right. This is surprising. This is probably the first time it's ever happened.
Right. Yeah.
What else is true about the image now?
It's smaller.
It's smaller. So our HI is going to change. So our P is now 50. Our Q is going to be smaller. And our HI is going to be smaller. Figure everything out. And you do this for 2 more images, 2 more P's. Then what we're going to do is we're going to move it inside this is hard. The focal length. In fact, it says to put it at 10, so that's at 65. We read it off here, 65. Now the bad thing here is you can't see the image on the target anymore. You can only see it through here. All right, and you can see it though. It's there. Trust me. Might have to move it up a little bit. You can see it better now?
Can you see that?
All right. If you can't see it, it's probably Greg's fault. He's the one doing the videoing. But trust me, it's there. Bibu sees it. Bibu, you see it, right?
Yeah.
Okay. And you're supposed to say, no, I don't see anything. What are you talking about? Okay.
We'll make them full.
Now in this case here, you can't measure the image on this side here. You have. So what you do is you actually measure it using the. You can see the image here, and you can kind of estimate. Now, keep in mind, what's true about the image now, though? The arrow is pointing up, just like the real thing. So, yeah, this is kind of difficult. I don't know if I like this. But trust me, you can do it. Okay? And that's how you have your P, which is going to be 10. All right? You have your HI estimated. You have the focal length isn't going to change from the beginning of the experiment. Now, how do you figure out Q? Do you have an idea, Greg? 'Cause I don't know. I just realized I don't know. I guess about the best thing you can do here is use your... I don't know. Do you know how to measure Q?
It's a virtual image, so
Yeah.
I'm not sure that you can.
I'm not sure that you can either.
Talk about
Well, if I figure it out or something like that, I'll let you know. But that's in part 2 anyway, so don't worry about it, because by then I'll have it figured out. Okay, so that's the focal length lab. Does anybody got any questions? Oh, I forgot. This is a video. You can't ask any questions, except Bibo, and he doesn't have any questions, do you, Bibo?
No, I got it.
Okay, so now all we need for today is the secret code. What's the secret code? Anchovies. Anchovies. Okay, you got that? I'll see you in the physics lab.